Okay, now we want to take a look at the second problem, which is basically sketching sets of points. And we notice that this first set of points is going to be related to a circle because it has the following form. It has the form z minus z naught, and there's a constant on this side. Okay? And if there is an equal sign, this is just the circle. Okay? If there is an inequality, this means the inside of a circle. And if it's greater than, it's the outside. Okay. So this is a circle that's centered at z naught and has radius c. Okay, so let's go ahead and put it in this form, okay? So if we do this, we notice that we have z minus, and this is going to be 2 minus I is less than or equal to 1. So this tells us that this is a circle and its interior and the circle is centered at z naught is equal to 2 minus I, or I could write this as 2 negative 1 in the complex plane, and the radius is equal to 1. So let's go ahead and draw what that would be, okay? I'm going to go ahead and insert a coordinate system here real quick. And bring this down just a tad. And let's see, there we go. That looks good. Okay, so here I am. My center is at 2, negative 1. Okay, it's down there. Let me see if it'll let me write on this. It might not. Yeah, it will. Okay, and then the radius is 1. So I'm going to go out in 1 in each direction. And this is my circle right here. Okay. It's usually not a bad idea when you draw a circle to label these 4 points, okay? So this is going to be at the point 3, negative 1 here. This will be the point 2, negative 2 here. This will be the point 1, negative 1. And finally, this will be the point 2, 0. Okay, good. All right, let's look at the second problem. So here, and we can see this is going to be the exterior of a circle, right? Let's cut that out. Okay. So again, I'm going to put this in our kind of standard form, but I'm going to realize that in order to do that, I have to factor out a 2, right? Because notice that the form is z minus z naught. It's not something times z, okay? So the first thing I'm going to do is I'm going to factor a 2 out of there. So this will be z plus 3 halves is greater than 4. And I'm going to use the fact we have this rule. You probably remember this before. We have a rule that says if we have 2 complex numbers being multiplied, the modulus of their product is the product of their modulus. Okay, and so I can think of this as a complex number. So it follows from this that I get the absolute value of 2 times z plus 3 halves is greater than 4. Of course, this is just 2. The absolute value of 2 is 2, and I can divide on both sides. And I'm going to get this. And finally, I'm going to write this in our standard form. I'm going to say z minus, and when I do, I'm going to have a minus 3 halves here. Okay. So this is going to be a circle that's centered at minus 3 halves with a radius of 2, but I'm only looking at its outside, okay? I'm not looking at the circle, just its exterior. So we have to be careful when we plot this, okay? Let me show you what I mean. I'm going to go ahead, I'm going to insert it. Never mind. Okay. Let me see. I'm going to blow this up a little bit because I want to show you clearly what I mean here. Okay. So first of all, it's centered at minus 3/2. So 3/2 can be minus 1.5, right? Okay. The radius here is 2, so I'm going to go over 1, 2 here, 1, 2 here, and I'm going to go up 2 here, and 2 here, down 2 here. Okay. But notice that the circle's not included. It's just the outside. So the way I'm going to draw this is I'm going to draw a dotted line, and that's going to indicate that the points on the circle are not included, okay? So this does not include the points on the circle. That's what that dotted line means. Just the points on the outside. So the way I'm going to do that is I'm going to go ahead, I'm going to shade the outside here like this. Okay. Just going to shade the outside of the circle. So it'll look like this. Okay? So it's not the points on the circle. I'm kind of slopping over there, but that's okay. It's just the points on the outside. Okay. So that's my solution right there. Okay, good. All right, let's look at the next one. Okay, imaginary z is greater than 1. Well, we remember, and I'm gonna, no, that's okay. I'll do them on separate problems. I was gonna do them on the same problem for a second, but I won't. Okay. Remember what the imaginary part of a complex number is. It's the y component, right? So the way I'm gonna think about this is, remember that imaginary z is equal to y, which implies we're going to have y greater than 1. And of course that's easy to draw on a plane, right? I won't bother even making a special sketch for that. I just take y equal to 1, and notice that I'm not going to graph the points where y is equal to 1, just the points above it, right? Okay, so again, you know, I'm going to fill in everything above that line. But notice again, I have a dotted line because the line y equal to 1 is not included, okay? And let me make this really thick so it's clear. Okay. There we go. All right, good. Okay, let's look at D. So D, we have the imaginary portion of z is equal to 1, and you can see it's really the same as the last problem pretty much, right? Because we know that the imaginary part is always y. So we know automatically what the answer is. It's just y equal to 1, and I can easily plot that, right? Here's my x, here's my y. Y equal to 1 is just this straight line right here. And that's it. Okay. Let's look at E. So E is dealing with the argument, okay? And the argument is the angle. It's actually the polar angle. That's how you want to think about the argument. When we put a complex number in polar form, the argument is the polar angle. So what we're going to do is we're going to realize that this is basically talking about the set of points where the polar angle is between 0 and pi over 4, but we're not including 0. So we have to be a little careful how we plot this, okay? So let me show you how it's done. It's a little tricky. what I'm going to do, I'm going to blow this up. Okay. Now, we know that pi over 4 is y equal to x, okay? So here's what I know, and here's why we have to be a little careful when we do this, okay? Okay. So this is the line theta equal to 0, right here. And this is the line y equal to x is the line theta equal pi over 4. Okay? And I want all the points in this sector, except I don't want to include zeros, so I have to put an open circle here, okay, to indicate that 0 is not included. And now all I'm going to do is I'm going to highlight everything in this area. Okay. So these are the complex numbers whose polar angle is between 0 and pi over 4. But we can't let 0 be in that set. Okay, good. All right. So let's look at the last one. The last one's a little tricky because if you look at it, you notice something. It looks like the equation for a circle first, except there's a problem, right? And the problem is that what is on the right-hand side is not a number, right? So we're used to this looking like this, right? We're used to something of this form, you know, z minus z naught. But then on this side we have a number. We'd have something like c, but here we don't. We have the variable. So we have to be a little careful on how to do this. So what we're going to do is we're going to go ahead and we're going to set up this equation, okay? We're going to notice that z minus 4, the absolute value, is equal to the square root of, okay, x minus 4, quantity squared, plus y squared, square root. Okay? And we know that the absolute value of z is just equal to the square root of x squared plus y squared. So this tells us, our inequality tells us, that we're looking at the x and y that satisfy this equation. Okay. Now, because both sides are positive, when I square the inequality, the direction of the inequality holds, okay? So I'm going to square both sides, and I'll end up getting this. Notice that the y squareds cancel, and when I bring the x squared over here, I end up getting minus 8x plus 16 is greater than or equal to 0. Okay? So I'm going to subtract y squared from both sides, and I'm going to subtract x squared. And now all I'm going to do is I'm going to solve for x. Okay? So you can do this a number of different ways. I'm going to bring the minus 16 over here. And I'm going to divide by minus 8. And remember, when we divide by a a negative real number, it reverses the sign of the inequality, right? So this becomes x is less than or equal to positive 2. And so, of course, I can easily graph that, right? Here's x equal to 2. And I'm going to shade in everything below it. X is less than or equal to that. So it also includes all of these values here. Okay, and that's going to be my answer. Okay, that's it for the second problem.